Hey, hi guys, welcome you all to the post content discussion of the LeetCode contest. Today we will be discussing the solution for the problem A and B. Let's start with problem A. You are given an integer array nums with length 3 divisible by 3. You want to make the array empty in steps. In each step, you can select any three elements from the array. Compute their median and remove the selected elements from the array. The median of the odd length sequence is defined as the middle element of the sequence when it is sorted in decreasing order, non-decreasing order. Return the maximum possible sum of the medians computed from the selected elements. Let's discuss the question in very detail. So you are given a question. In the question, you are asked that you need to find maximum possible sum of the medians, right? So let's say what is median? Median is middle element of the array. In this question, we are only having odd length arrays, right? In this, the there should be must be a middle element. So that is the median of that element. And you are also asked to have the median should be middle element and the sequence which you are taking as size 3. Let's say this is this is the sequence. It should be sorted. It means that you should have 1 2 3. It should be sorted. It means that you will be having 2 is the middle element, that is the median. So before that, I just want to tell you that what is the subsequence. Let's say this is the array. You need to generate all the subsequences. Subsequence is nothing but you can delete 0 elements or more elements. Let's say this is also one subsequence which you are deleting 2 elements. This is also one subsequence. This is also one subsequence, and this is also one subsequence, and you can also having 1 2 and 1 3 also a subsequence. Next, you will be having 3 as a subsequence, in which you are following order here, right? And if you can take 3 and 1, it is not allowed because you are avoiding the, you are actually not following the order here. You need to follow the relative ordering. The 2 should be after 1, 3 should be after 2. So this is the, we need to maintain order here, and we are delete here, we are delete in this subsequence. You can check we deleted 2 elements, right? After 2, so we had deleted this element and this element. So these are the possible subsequence formed with the 3 size subarray. But in the question, you are initially you are given array which is non-sorted, unsorted, right? Let's take 1 3 2 4, and you are asked that you need to take any three elements, that is 3 size subsequence, right? In the subsequence, I will take 1 3 2. This is one subsequence of size 3. And in this question, you are given that the n length of the array should be must divisible by 3. It means that you can partition the array into 3 sizes, such that when you are selecting the first subsequence of, if you are selected this one, you are actually removing the complete 3 size sequence from the array. Let's take this one. We are choosing this one, this one, this one, right? In this, you can see here, and I am choosing the three elements. This is a subsequence. We need to sort this. After, we need to sort this 1 2 3. So this is what the sorted sequence is. In this, we need to take middle element, that is 2. In the size 3, the middle element is this one, and we need to add this to our answer. What is the another possible sequence you can actually form with that 4 elements? So the another possible sequence is 1 2 4, right? So this is also sorted. The 2 is median. We are getting same median here. We need to maximize the median here, and, and also we need to follow that it should be sorted. And again, what should we be having? We would be having 1 3 4, which is also sorted, and which is giving the maximum possible sum. Let's see, if you are having sequence of 1 3 2. So he's saying that each subsequence should be sorted. Doesn't it mean that the complete array should be sorted? Yes, it is, right? You can observe that when you are actually having elements like 1 1 3 2 4, if I will sorted 1 2 3 4, when you are finding the subsequence of size 3 and you are sorting, is it same as that if you sort the array before you are taking the 3 size subsequences? And after that, you are asked that you need to find the maximum median, right? So in this subsequence, let's take some subsequences which is bigger. 1 2 3 4 5. This is the array. This is the 6 length array which is divisible by 3. In this array, you can see here that I can form subsequence. I want the maximum possible median, right? I can take first element. I can take first element, and I can take last element as 5. So this is how we need to follow the subsequence ordering here. and the middle element should be, I will take this as a middle element. I will be deleting after choosing the subsequent. You need to delete all these elements, right? After what we are left with, we left with 1 2 3, right? Next I will be choosing 1, and this should be the last third element, and the middle should be the 2 here. So what you are observing here, you are getting 2 plus 4, which is the 6. This is only the maximum possible what sum you will be get in this test case. So here we can simply observe that when you are sorting the array, you will be finding that you are pairing the first element with the last element, right? This is only one the possible case. You cannot have like 1 5 4, because you are actually avoiding the you are not following the order here of the subsequence. So there must be one should be at the come first, five should be come at the last in the three size subarray, and you are taking this the element which is next to the five as a median element, right? After that, what you can do is, in the next you will be having like, you need to delete this element, you need to remove this element. 1 4 5 done. Next we are left with the three elements. In the three elements, what you can do is, one which is the smallest element in the array, and the which is the last element should be come at the last, and what should be the maximum element. You can think that the element which is immediately after the three, the immediate element after the three, it should be the maximum possible median you can get in this array. So the answer would be like, what you have got, 2 plus 4 6. This should be the answer in our question. Let's see the question once. So let's see, 2 1 3 2 1. Let's try run the test cases here. Test case 1, we are given 2 1 3 2 2 1 3 2 1 3. The test case is 2 1 3 and 2 1 3. What you can do is sort. You need to sort first. 1 1. Next is 2 2 3 3, right? What you can do is, you can actually pairing the smallest element with the last element which is possible element. You cannot pair less than that element, right? So you, and what do you think that median should be this one or this one or this one or this one for this chosen subsequence? I am choosing first element this one, last element this one, which is possible. That is only the possible thing you can do. After that, I will selecting the immediate element after that element, that is 3 here, because it would be giving me the maximum possible medium, right? And after that, in the next, this is one possible way. After I will be delete this one, I will be deleting this one, I will be deleting this one. You are left with 1 2 2, right? In this, the smallest one is 1, and the last one possible, only the possible one is 2. You cannot have a less than that or more than that. The median should be the median should be the immediate after element the 2. The median is the immediate element which is coming after the 2, so which is 2, which is only the possible maximum value will be actually provided. So 3 plus 2, which is 5, is the answer for the test case. And there is another test case like 1 comma, not 10 comma 1 comma 10 comma 10. Let's see. Sort it 1 10 10 10, right? So you can pairing 1 with 10, 1 is first and 10 is last. After that, the maximum possible median should be the element of, before the 10, right? That is 10. So this is the median element, and what you are left with, you are only left with one element. You cannot form any subsequences of size 3. That is our answer. So let's see how we are following here. 1 1 2 2 3 3. So let's take 0 1 2 3 4 5. This is the indexing. What you can do is, you don't need to extract this all the subsequences of length 3. You can actually simulate just using the tracking the sum of the maximum possible sum here directly. So this is the last element for the subsequence, and this one would be the mid, which I can actually form with. You can observe here, 1 3 3 is the one subsequence, and you are deleting this one. Another one is 1 2 2, right? So this one would be the two subsequences which you are forming from this array. Let's see, 3 which is fifth index, 2 which is third index. You're actually jumping back at the two places. And let's say what will be the size of this array? N is equal to 6, right? If you can divide with 2, you can actually jump in two places from the back. So you are standing at this place. This is the initial first mid which you are getting. From here you can actually jump into this mid here, not from to here to here. You are jumping actually from the n minus 2 to the previous second L. So let's see from the code. What you can do is, I will be actually starting from the n minus 2 because this element is fixed in the size 3. 1 comma 3 is fixed. The middle element should be this element. The initial element is n minus 2. And what I can do is, what should be, how many steps we need to go for here? K is equal to n by 3, right? We need to only go for the n by 2 steps so that we will get, we need to have, we want only k medians here. So we will be go k minus minus. After that, we will be simply adding some place is equal to what, array of I. And what I can do is, I can simply decrement I minus is equal to 2 here, which is, from here you actually, from here you are actually jumping back to the two places. Let's take another test case so that you can actually write code in very simple language. 1 2 3 4 5 6 7 8 9, right? Let's see the how we are simulating. We're standing, initially we're standing at this place because these two elements are got fixed, and this would be the maximum possible median you are getting. So sum is equal to 5 plus, you are actually deleting this element. You are next, you are pairing this two element with this element, and the next two median would be, maximum median would be 3, and you are deleting this element, and you are deleting all this element up to here, and you are pairing 2 with 3, right? And so the next two possible median would be this element, so that is 2. So what would be the answer? 10 will be the answer for this test case. So let's see, from here you are jumping to here, from here you are jumping to the here. So this is how you can see. This question is slightly observation based question, you can observe the things, and you know, no need to extract all these subsequences of size 3. You can directly go to the observe, you can observe little, you can actually get the idea. Let's see the code. So what I can do, actually find the length of the array. After that, I take in how many elements I can have in my median sum, right? So if k array size is 6, then I can have only two median elements. So that in 6 I can have uh, two parts of length 3 subsequences. After that, I'm sorting that array, and next I'm taking long sum is equal to 0. I am starting from the last to second, right? And I will be just jumping to the number of steps, the number of median elements that would be required, and simply adding that, and I will getting back to the two steps. I'm returning the sum. Now let's discuss about the problem B. So let's read the problem once. Maximum number of subsequences after one insertion. You are given a string S consisting of uppercase English letters. You are allowed to insert at most one uppercase English letter at any position, including the beginning or end of the string. Return the maximum number of LCT subsequences that can be formed in the resulting string after at most one insertion. A subsequence is a non-empty string that can be derived from another string by deleting some or no character without changing the order of the remaining character. Let's discuss the question in very detail. So we are given a string. We are given string S such that you can do one operation. That operation is, in the string you can actually insert L, or you can insert C, or you can insert T at any position in the array, in the string. So the question is asking that you need to return maximum count of LCT. LCT is a subsequence. Subsequence means just choosing LCT from the given string. And what we can do is, let's observe little here. To form a subsequence of LCT, what should you have? We will just observe here. If you have C here, you definitely need to have L of before the C, and you definitely need to have T after C after T. So what we can do is, let's say we are standing on the C and we are checking. Is there any L before this C? Is there any T before T which I can form subsequence of LCT? So this is how we, we can observe here. After that, what we can do is, now let's see. I am having L L C C T T T, and you are just standing on the C and you are asking to the C how many L you are having before C, right? And after how many L's you are having after C. This is in this part you will be having after C it will be asking number of T's. You will be having 3T here, 3 T's here, and you will be having 2 L's here. So how many possible subsequences which can form by LCT? It is very simple, that 2 into 3 which is 6. It is a simple combinatorial, right? So like that, we can actually generate all these subsequences of LCT using this technique. So we just maintain. How can you track the all the L's before the C? So we just maintain a prefix of L, right? And we will be maintaining suffix of suffix of T. And when you are standing at the particular index, let's say if if I is equal to C, this is the character which you are getting, then the possible answer would be the number of subsequences which is of LCT is prefix of prefix of just before that this index. So from this index, this is the part which you are having prefix, right? Prefix of L. So that is I minus 1 into suffix of what? uh, I plus 1. What you can actually getting? So if you are this is the C, you are actually asking number of L's before C, and after C I plus 1 means from in this part you are asking number of T's. You are just multiplying, you are getting all the LCTs. But the question is that you need to insert any character such that you can maximize the count. So what we can do is, let's say if you want to insert L, what you can do, you can definitely insert L before that. That could be contributing more. Let's say if you inserted L and your got increased the count, got increased 3. So you if you so that then you will be having, like, let's discuss L L C T T T, right? Let's say this is which is the L part, this is the which is a T part. If I'm standing here, I would be just calculating the number of subsequences of LCT by this formula, right? I will be maintaining the prefix of L, and I will be maintaining the suffix of T. And I'm simply standing on this C. I will be asking how many L's before you, means how many L's L you have already seen. So it will be saying that L count is 2. How many is T after you? It will be saying the 3. So it would be 2 into 3, which is 6, right? What you can do is, let's say first case is, what if I insert L? So there you can observe that you can definitely add L at the beginning. You cannot add L here because it is not contributing. You cannot add L here, it is not contributing. You can definitely add L before C. So let's increase the count of L here. L will got 3, T is got 3. You got that 3 into 3, which is 9, which is the maximum possible. What if I can what you can do is, if if I want to add if I want to add L, I can add at the beginning. If character is the character is what? If the character is T, I can definitely add at the end, right? That will be contributing more. What if I can add, let's say in this test case, if I will be add T, then I can say that T count is got increased by 2, 4, and L count got increased by 2. Then the number of some subsequences of LCT is 4 into 2, which is 8, right? Which is we are getting maximum possible. So if you add T here, you cannot, it is not contributing in the LCT. So that is the reason we are adding T after the C, and L of before the L. L is adding before the C, T is adding after the C. So this is how there are the three cases. So you got that. The original answer is the original answer is the original answer is like prefix of I minus 1 into suffix of I plus 1, right? And this is the original answer where when you are standing at the if ch is equal to when you are standing on the c and you are asking that how many possible LCT you can form with prefix and suffix characters. After that we need to think about the insertions here. Insertions, right? So the first insertion would be definitely we will be having insertion adding L. What you can do is this is what the and we will also having we will maintaining answer of L, which is contribute the answer forming by the maximum possible answer after inserting L. What you can do is you are just answer place you what you are doing is prefix of I minus 1 plus 1. Let's store prefix of I minus 1 and suffix would be suffix of I plus 1, right? What you can do is if you are adding L means let's say LLC TT. So this is the L is equal to 2, T is equal to 2, C is equal to, let's see. If you are adding L before the C, that means you are actually increasing the L count here. It means the L got increased by 1. So you are actually having 2 and you are adding P plus 1 and you are multiplying with the suffix S, right? This is what the case of adding the inserting the L and we are storing this result into the different answer here. And the next one is when we are adding when we are adding T here. We are adding T to the suffix, right? P should be remain same, but S should be got increased by 1. So this is adding of T here. So we are done with how we are adding S and T, L and T. Let's see how we can add C. So this is where the L L T T T C. So what is the possible cases that I can add C so that I can get maximum? When I am traversing, I will be check on every index and I will store the maximum possible answer here. So how should I get this one? If it is not C, let's say, then I'm starting at the index. I will be asking the number of L before this index. So there is no L. I am asking that number of L before you. L is equal to 1. If I want to insert C here, what could be the possible? L before C, I got one L here. L into number of T's after this from this index, right? This is the index where you actually having number of pieces, that would be 3. So if you insert C in this position, we can actually get 3 subsequences of LCT. So like that I will be insert here and I will be simply check that number of L before that character and number of T's after that character, and I simply track my answer and I will be also taking the maximum of that. From that we will be having maximum 3 cases, right? Let's see the question once. So let's discuss this one. First test case, that is LMCT. We can actually see this is a subsequence which is already having LCT, and the next one is this is only possible one, right? So the next two, and we can actually perform one operation here. So the operation is can insert any of the character LCT. If I insert L before here at the beginning, what I could get LCT another subsequence. We got two subsequence here. So if you can add C, you will only get 2. If you add T, you will only get 2. So let's see what would be the possible cases. We will be having some possible cases, right? The answer one is the case where we are actually having when we are inserting the Then we are inserting the C at each position, and we are tracking the uh, Li means all the else before the I, and Ti means all the T in the suffix. And the next possible one is what we will be having from for I to 0 to n, we will be having for each C, if ch is equal to C, we are having, we are inserting L plus 1, and we are multiplying with T. T means the number of prefix T after this index. And if we, what if we insert T here for the, for I is equal to 0 to n, if character is equal to C, then I would say that L is remains same, we are adding T. T means T plus 1. Here we will have multiplying. These are the possible answer which we can generate, and we will taking max of answer 1 comma answer 2 comma answer 3, right? So this is the possible cases we can actually generate. So this is slight observation based question, and if you can see the code, you can actually get more idea of the question. Initially, what I will be pre-computing the prefix and suffix of the all the T's and all the L prefix of, for each index I will be calculating prefix of all the L's, and after that I will be calculating suffix of all the T's, and next I will be tracking. This is the original answer if you are standing at the particular index, right? And this is the case. This is first case is LLCTT. When you are standing at this C, you are multiplying this one and this one. This is a suffix, this is a prefix. That is L1 T1. That is L1 into T1. That is as same as this case. Okay. Next one is we are inserting L here. So inserting L means nothing but we are adding one to the prefix of particular index, right? And if you are adding T means you are adding one to the suffix of particular index. And at last you will be having that case when we are actually inserting the C. This is the special case in this LLTT. So you are trying to insert at every position. You are checking the maximum possible that you can form. If I put C here, what I can form, what I am in suffix, I will be having one L here, one into number of T is 3, which is 3, right? What if I can add C here? What I can, if you add C here, you will be having two L's, right? Two L's and three T's. What could be the possible? 2 into 3, that is 6, is the possible maximum count of the subsequence of LCT. This is all about the question. So let's discuss about the time complexity in the code here itself. Let's, so you will be maintaining the three answers, and one is the final answer there. Initially you will be, here we will be actually fetching the prefix count of the L at the particular index, suffix count of the all the T's at the particular index, and you are calculating. If you are standing at the C, you are looking the previous all L's and all the T's after that particular index, right? And next you would be having three operations. You are adding L and you are checking, is it that maximum I will get, and you are adding C and you will storing that. After all this, you are actually taking the maximum all the possible after inserting LCD, right? So this is all about. You can see the time complexity here. It would be running for the, O of n times, and it would be also definitely running for the O of n time. And here we will be having O of n. So at the last, we can say that this is also running O of n times, and next to it, that's all. So completely, the time complexity would be the O of 3n 3n, so you can actually remove the constant from there, and the space complexity would be, I think we are using two vectors here, right? That would be definitely the O of 2n. So just remove the constant, you will be get n time complexity, n space complexity. That's all about the today's post contest discussion.